Hi all. This week the topic that we're going to be looking at is the topic of time travel. It's a nice topic, it's quite good fun. And in this first video I'm just going to really talk about the question that we're going to be asking about this. And as a first go at this, we're going to be addressing the question, is time travel logically possible? Alright, so it's the notion of logical possibility that we're going to be interested in. And I'm going to say a little bit about what logical possibility is. That's a Y, that's a T. Sorry about my writing. And a way of getting, well, first of all, by the way, when we talk about possibility, possibility and necessity come together. We have to understand both of them together. And just to kind of illustrate this, when people write the kind of modal logic, that is logic to do with possibility and necessity, so the term modality is to do with possibility and necessity. So, that there, possibly P, so this diamond is to be read as possibly. So if we have P, might be something like pigs fly. Oops, pigs, that's, oh God, fly. That would say possibly pigs fly. And it means something like it could be that pigs fly, or it's possible that pigs might have flown, something like that. We're talking about, it's not actually the case that pigs fly, but it could have been that pigs fly. So that's to say, there is a way the world could have been where there were flying pigs. And that's what that represents there. It doesn't represent epistemic possibility, so sometimes there might be, we might say something like, well, it's possible. What might we say about this? If I say, is my laptop upstairs at the moment? Well, I left it there, but somebody could have moved it, so it's possibly it's not upstairs. That just means, as far as I know, it's not upstairs, something like that. Here we're not talking about that sense where related to knowledge, we're talking about what's actually, like what's really possible. So possibly P is there meant to represent, it could have been the case that, whatever it might be, in this case pigs fly. One thing that's worth noting is whatever is actual is possible. So we might represent that as the following principle. If P, then possibly P. So that just means, for example, that things that actually do happen are certainly possible, and we want that to be true, right? Because if it wasn't possible, then how could it actually be true? Whatever is true must be possibly true, right? So, Paris is the capital of France. That's true. So it's possible that Paris is the capital of France is going to be true on this view. Whatever is actual is possible. But I just wanted to, the reason I'm introducing these symbols, we're not going to talk much about, oops, what's happened there? I don't know what that ruler is. We're not going to be talking much about, how do I get rid of that? I'm just going to put it down there. We're not going to be talking much about the symbols here, but it's worthwhile noting that the corresponding symbol for necessity is like that. So necessarily P, in this case it will say, if we have P, necessary that pigs fly. Well, that's false. It's not true that pigs fly, that have to fly. In fact, they don't fly in this world, so it's not the case that it's necessary that pigs fly. But possibly, if we have P equals 2 plus 2 equals 4, perhaps that is plausibly a necessary truth. Necessarily 2 plus 2 equals 4, so then this would be true. Notice also that if something is necessarily true, then it's also got to be possibly true. So, we've got P entails possibly P. We also will have P entails, what can we say? Oh, sorry. We're going to have necessarily P entails possibly P as well. If something is necessary, then it's possible. So if something's actually, it's possible. If it's necessary, it's possible. And indeed, we can define the notion of necessity in terms of possibility. So possibly P is true if and only if it's not necessary that not P. So don't worry too much about that, but we can define the box in terms of the diamond, and we can do it likewise, necessarily P if and only if not possibly not P. So those are two principles, and that just means we can define necessity in terms of possibility, and we can define possibility in terms of necessity. It doesn't matter which way we go. But okay, don't worry too much about the boxes and the symbols and the diamond there. Really, it's just, well, let's introduce the next bit. So we're going to understand this. So if P is possible, then what we're going to understand this to mean is P, in fact we're going to have it stronger than that. P is possible if and only if P is true in some possible world. So we're going to think about it in terms of possible worlds. So a possible world isn't just meant to be, just to emphasize this, I think you're probably familiar with this idea now, but a possible world is not supposed to be an actual planet out there that we can go and visit. A possible world is like a possible universe. It's a way the world could have been. So for the sake of this, we're going to imagine that every way that something could have been, then there is a world that is that way, right? So if it's possible that pigs fly, that means that there is some possible world in which pigs do fly, right? If it's possible that you could have had cornflakes for breakfast, even though you didn't, then what that means is there's a possible world out there where you, or at least the counterpart of you, did have cornflakes for breakfast. And then we're going to have this P is necessarily true, or necessary, we'll just say that. P is necessary if and only if P is true in all possible worlds. Okay? So 2 plus 2 equals 4. That's necessarily true, because no matter which possible world you go to, it's true in that world. So there we go. And by the way, all those implications that I spoke about earlier are going to apply here. So for example, if something is actual, then that means that it is, so, dogs bark is actual. It's true that dogs bark in the actual world. Well, that means because the actual world is one of the possible worlds, then the proposition that dogs bark is true in some possible worlds, so it's possibly true. So that was to say the principle that if it's actual, it's possible. That follows on this framework. Likewise, if something is necessarily true, so 2 plus 2 equals 4, well, if it's necessarily true, it's true in all possible worlds, and therefore it's true in some possible worlds. If it's true in all of them, it's true in some of them. So therefore what's necessary is also possible. And the interdefining of these things, so to say that something is true in some possible world is to say that it's not the case, not the case that it holds. Oh right, hang on, how are we going to get this? It's not the case that I'm going to have to write it out in terms. So this is the idea. Possibly P, if and only if there is some world W such that P is true in W. Okay, and necessarily P, if and only if for all W, P is true in W. Okay. So at any rate, this we're going to turn out to mean, so to say that something is possible, so if it's true, if there is some world W such that P is true in W, well, this entails that it's not the case that for all worlds, that it's not the case that P is true in W. Don't worry too much about this, but this basically gives us this idea that we can define them. And notice, by the way, that when we do this, possibly P actually gets interpreted as being an existential quantifier over worlds, and necessarily P, I'll put it that way, it becomes a universal quantifier over worlds. So I'm aware that perhaps this won't make too much sense to you, but for those of you who like it in logic, I know some people do, then this might help. But it's the word definitions that matter. Okay, so we're here thinking about, so you can get rid of all that as long as you understand those. P is possible if and only if P is true in some possible worlds, and P is necessary if and only if P is true in all possible worlds, right? So, in fact, to say that something is necessarily false is to say that it's true in no possible worlds, right? So, 2 plus 2 equals 5. 2 plus 2 equals 5. That isn't true in any possible world, and therefore it's logically impossible, right? Well, I'm going to say a bit more about that. But if something is false in all possible worlds whatsoever, then it's going to turn out to be logically false. But I do need to make one further distinction here, which is this. So if we imagine the actual world, now we're going to draw a little space of possible worlds, and let's imagine here's one possible world. So this isn't representing a universe with planets in it or anything like that. This is the space of possible worlds. So this represents the actual universe, the entire universe, which is usually labelled using the ampersand. So WA means the actual world, so that's what that represents. And these are all other possible worlds where things happen which don't happen in our world. We can label them W1, W2, W3, W4, etc. and so on. I won't label them all. So those are all different possible worlds where different things happen. But what we're going to suppose is that within each of these worlds, the laws of nature that hold at the actual world hold in these worlds. So we can call these, this group here of possible worlds, and there will be, by the way, well, how many? Infinitely many, probably, of these. You know, there's infinitely many different ways in which the world could have been, consistent with the laws of nature. So here we're going to say, same laws of nature hold. So in all of these, in this little circle, the same laws of nature hold. So, you know, whatever the laws of nature turn out to be, whether relativity theory's got it right or quantum mechanics, the same laws of nature hold. So these are what we might call the nomologically possible worlds. Alright, nomologically possible worlds. So these are the worlds, the nomologically possible worlds is just a set of possible worlds in which the same laws of nature hold as hold in the actual world. Okay. So sometimes when we talk about possibility and necessity, we're talking about nomological possibility. If I say something like, oh, well, it's not possible for somebody to travel from John O'Groats to Land's End in a quarter of a second or something like that, because, you know, it would break the light can't travel that distance in that time, and light is the speed limit of the universe according to the laws of nature as we think they hold. So I might say it's not possible for somebody to travel from John O'Groats to Land's End in a quarter of a second. And what I mean by that is it's not nomologically possible. Given the laws of nature, it's not possible for somebody to do that. And that's another way of saying that there is no possible world within the set of nomologically possible worlds in which somebody travels from John O'Groats to Land's End in a quarter of a second. Okay? So there we're assuming the laws of nature. But, you know, possibility is broader than that. And we can imagine, look, the laws of nature don't hold as a matter of logic. They're not logically necessary. There are other possible worlds where the laws of nature don't hold, so we think. And these are the ones outside. Perhaps they've got other laws of nature that hold within them, or perhaps they've got no laws of nature whatsoever, if that notion makes any sense. Maybe it does. So this broader set, which includes the nomologically possible worlds, by the way, are called the logically possible worlds. Right? So outside of the inner circle, in all of these worlds out of here, are worlds in which the laws of nature don't hold. So they're included within the logically possible worlds, but, you know, so are the ones where the laws of nature hold. So these are the logically possible worlds. Worlds, oh god, LDS. And, you know, there might be a world, there might very well be a world there where somebody travels from John O'Groats to Land's End in a quarter of a second. They just happen to break the laws of nature that hold in our world. But, you know, why not? So W6, I'll just continue to label, and we'd have to label all the rest in W7, W8. So, okay, I hope that makes sense. And what this means is, if something is nomologically possible, if it's possible given the laws of nature, then it's logically possible, because it's contained within, right, the logically possible worlds. But it doesn't follow that something is logically possible, that it's nomologically possible, because there you might have a world that's outside of the nomologically possible worlds. Okay? So I hope that makes some sense to you. We're just distinguishing between two senses of possibility. And now the point of this then is, when we're asking about time travel, what we're really asking is time travel logically possible, as I've said? So we're thinking here, we're not thinking about whether it's possible given the laws of nature. So we're not supposing that the laws, we're just asking, okay, is time travel possible in this broadest sense? And one way to think about this is, does it give rise to a contradiction? So the idea is, well, within all of these worlds, there are no logical contradictions. And that's really basically the measure of whether something is logically possible. Do we have to suppose that there's a contradiction involved? So I'll put it this way. There's no world in here in which there are square circles. We can know that. That's logically impossible. So why? Well, because something being a square involves it having four sides. Something being a circle involves it having one side. So nothing can have both four sides and one side at the same time, because having four sides means not having one side, and having one side means not having four sides. So to imagine that there's a square circle would be to imagine, or to suppose that there's a square circle, or that there could have been a square circle, would be just to suppose that something could both have four sides and not have four sides. That's a logical contradiction. So there is no world in which square circles exist. It's not logically possible, right? Whereas something like, as I said, somebody travelling from John O'Groats to Lansdowne in a quarter of a second, well, that's not nomologically possible. It's not contained within the worlds in which the same laws of nature hold as at the actual world. But there doesn't seem to be any logical contradiction. There's not a contradiction involved in supposing somebody travels from Land's End to John O'Groats in a quarter of a second. So that's logically possible. Okay? So what we're really going to be interested in then is, are there any worlds in which time travel occurs, right, at all within this? Right? It might be that time travel is also nomologically possible. It might be that the laws of nature allow time travel to occur, but we're interested in the more fundamental question about whether it's logically possible. Because put it this way, if it's going to be nomologically possible, it better as hell be logically possible. So if we can establish that it's not logically possible, then we're going to establish that it's not nomologically possible as well. Because if there is no world within the broader sphere, which includes the inner sphere, in which time travel is possible because there's a contradiction involved, then it can't be true in the smaller sphere either. So that's the idea. Okay, so let me just sort of summarize this. So we're interested in the question, is time travel logically possible, as I've said? And this is the idea that time travel is possible in the broadest possible sense, right? The broadest sense that we can say about possibility. So, doesn't matter what the laws of nature are, doesn't matter about the laws of nature. Perhaps the laws of nature, perhaps the laws of nature mean that time travel is not nomologically possible. We can't do it, given the laws of nature. But we're interested about whether it's even logically possible. So what matters, this is the key thing to note, what matters is whether the idea that time travel happens, or that time travel occurs, gives rise to a logical contradiction. Logical contradiction. Okay, that's the key idea. And we're going to be focusing on backwards time travel. So really our interest is going to be in backwards time travel. For a reason which I'll talk about as we go. It's the more interesting sense of time travel. So there we are. That's kind of the ground set for this. And I'll get rid of the ruler like that. Look, that's the ground set. And yeah, in the next video, I'm going to be talking then about, well, what does it mean? What does this idea of time travel, in particular backwards time travel, amount to? So we're going to look at a definition of what time travel is. And then we're going to turn after that. So the third video is where things will get really kind of interesting. Then we're going to turn to the so-called paradoxes of time travel. So just to kind of give you the heads up, lots of people have thought that time travel, in particular backwards time travel, is not logically possible because it does give rise to paradoxes. It gives rise to contradictions that can't be solved. So that's really going to be, yeah, that's what we're going to be interested in. Okay, so thanks a lot. The next video then is what do we mean by time travel?